All right, hello everybody. Welcome to the session on maximizing browser performance with the Salesforce console. My name is Paul Higgins. I've been with Salesforce about 4 years on the customer-centric engineering team. And basically what that means is if you've ever opened a case about console and it's been escalated to R&D, there's a really, really good chance that that was me. So I hope I served you well. Before I get any further into this, I'll show our favorite slides. Safe harbor, anything I say about forward-looking statements may or may not happen, so make any buying decisions based on currently existing products. And that said, the agenda for this, I'm going to talk about some admin implementation tips you can take with your console application to avoid performance degradation for users. Then I'm going to go into how you can conduct performance testing in your own org, very similar to the way Salesforce does it, and that way you have a really good comparison of your performance versus what we expect the performance to look like if you do encounter any problems. Then there will be some time for some Q&A. So before we get too deep, I want to talk about what do we mean by performance. In this context of the presentation, we're talking about a slowness or a sluggishness or a lack of responsiveness in the console application that your end user experiences. It often manifests as your browser hanging or crashing or actions being swallowed up and never actually happening on the console. And for these purposes, we're measuring it by proxy with memory allocation. So the amount of memory that the browser is using roughly correlates to the performance your end users will see. Of course, we do additional testing on our side, things like experience page time and how long actions actually take to complete. But generally, we can use the amount of memory that a browser process consumes to indicate whether or not a user may be experiencing performance problems on their own machine. So one of the recommendations we make is that you use Chrome as a browser of choice, if at all possible. What we see here is a comparison of the memory consumption for web browsers over time. And the test we run is sort of a burst simulation. So if you're a call center user and 3 calls come in and you open a bunch of tabs at once, this is what this replicates. We'll open 10 tabs at once, let them load, and then close these tabs and see what the performance is over the case of 300 tabs, so a rough volume that you might experience as a user in a call center. And this isn't definitely a hard number, but once you start seeing numbers getting close to about a gigabyte of memory usage, that's when your users are at a high risk of experience a performance degradation or a problem. You know, on higher capacity machines, like a MacBook Pro with 64 gigs of RAM, you might not have a problem. But if you're using a Citrix environment where they have 512 megabytes of RAM and it's shared between users, you'll definitely start seeing problems before this happens. So the main thing I want you to think about as we go through these tips and tricks is the console, as it is built with iframes. Iframes basically let you load content from another source from the main frame the browser is showing. So here is a picture of our beautiful console for our friends in the Game of Thrones world. Who wants to shout out and guess how many iframes are in this picture? 50? 15? Anybody else? $1? 7? So you are the closest. It's actually 17 iframes. So in the console, every tab is an iframe. Every subtab is an iframe. Rich text editors, like you'll see with posting to Chatter or composing an email, they're iframes. Custom footer components are iframes. These sidebar components to send a raven or keep track of how many kings are still alive, those are iframes. And so this is probably one of the biggest performance impacts on the console. So everything we do, we want to reduce the number of iframes actively present in the console. So the first thing you can do as an admin, we have a feature called tab governance or setting tab limits. In each console app, you'll see on the right what it looks like. You can set a hard limit to the number of tabs you have open for a user. So just like when you use a web browser, if you open 200 tabs, you're going to have a bad time. So you can set your limits per user, and they won't be able to open tabs beyond these limits. We recommend setting this to 20 primary tabs and 10 subtabs. And this will keep users from shooting themselves in the foot simply from sheer volume of tabs open. And in conjunction with keeping the number of tabs down, we want to reduce the number of tabs that are automatically opened whenever possible. So for example, with OpenCTI or Live Agent, when a chat comes in or when a call comes in, you have the option to screen pop as many tabs as you want. You can open leads and cases and accounts and contacts. But if at all possible, we want to reduce that number. So if you know only 5% of the time a chat results in a new lead being opened, you can leave opening that lead to manual work for your agent rather than popping it automatically. And that will extend the amount of performance you can get from the console. The next one is merging custom components. So if you have Visualforce components in your sidebar, as I mentioned, each of these will be present in an iframe within the console. So rather than having two Visualforce pages which both display information from the same record, break those out into a Visualforce component. So each of these sidebars would be a Visualforce component. And then within a single Visualforce page, put both of those components. So you'd go from having two sidebars into a merged sidebar. And again, this has a great impact on the performance. It doesn't degrade the amount of information that's available to your users, so they still have the same amount of context and quality information within the console as before. And I'll wait for the picture. Along the same lines, we want to avoid automatically loading components that aren't needed. So like I mentioned, don't pop lead screens to people taking calls if it's unlikely that you'll get a lead off of the call. Load content on demand. So if you have a Visualforce page which is embedded within a page layout, and it's not often used, it helps to hide it. So in the top, we have an example of a component loaded when every record is opened. But what you can do is you can create a custom button, and when you click the button, it will open that component for the users. And so what we're seeing here is a trade-off between convenience for your users and long-term stability of the console in heavily customized environments. So as an admin, you need to understand what your users are experiencing, what their typical workflows are, and where you can make the compromise between adding additional click or two to their work for the benefit of performance in the long run. And so if anybody's rolling your eyes and doubting me that such simple things can make a difference, these are two real examples from real customers that really happened. I can't say who, but in the first one, they were experiencing problems where the browser would crash after a very short period of time. And so we worked with them to understand their customization and offer these exact same tips that we just went through. They changed two of their Visualforce components to load on demand, and they combined two of their components into a single component using Visualforce components. And the end result was they were able to open 6 times as many tabs before any problems appeared for the users. So it went from about hitting issues after 30 tabs, which is not very many, to 180 tabs, which was more than enough to get their users through the day. And the second customer, they're opening 6 to 8 components for every page. So whenever they would open an account or a contact, they had 6 to 8 extra iframes being rendered for the Visualforce pages. They were able to combine these to 2 components on a page. They saw a 50% improvement in memory use, and the problem was completely eliminated. So these are very simple tips you can take to your own console. It doesn't degrade the user experience, but if you are seeing some kind of sluggishness or slowness in performance, it can often be attributed to the memory consumption that the iframes that they have. And so those are the tips. I'm going to go into how you can test the performance of your own implementation in the same way that Salesforce tests our own console. And this will give you an idea that, can I safely add this Visualforce component, or should I merge it, or should I hide it? How do you know if it's actually safe to do what you're doing for your users? And so our testing methodology is pretty straightforward. We create a custom console component. It's built with a simple Apex backend, and it's got a Visualforce page that lets you choose from the suite of tests. And this is actually put into the console. And later on, I will demo this. The code is also in the slides. It will be uploaded to this session's feed on dreamforce.com. And eventually, we'll also get a blog post published with all of this code, so you won't have to memorize what I'm about to tell you. But this component with the Visualforce page, it automates the test using the Salesforce console toolkit. This is a JavaScript API that lets you control and manipulate the console. In this case, we're using it to open and close tabs automatically to simulate user activity. So rather than having you go into the console and click a tab and click another tab and fake some calls from a call center, you can do it automatically with these tools. And then we want to measure the results. We're going to use operating system tools that are built in to track the memory growth, and we're going to do a comparative testing between, if you like to think about it as versions of the console or versions of your page layout. So you'll take the test results of one layout, make a change, and take the test results of the next layout and compare the behavior. And you just keep repeating that until you're happy with what you see. And so because we're doing comparative testing between configurations, one of the most important things is making sure you get consistent numbers that simulate the reality for your users. So we recommend using dedicated machines if possible. Separate hardware. So get your own laptop, your own desktop just for these tests. If you have access to virtual machines, you can run it on a virtual machine, which I'm going to demonstrate shortly. But the key point is simulate reality. If your users are having a 4-year-old laptop with 1 gig of RAM, don't run your tests on a hyper-powerful Xeon server with 128 gigs of RAM, because what you see won't be what they see, and we want to eliminate that kind of discrepancy. We want to manage the processes that are running on the testing machine, so don't be running HD video compression while you're trying to do this. So when you're testing the browser, again, simulate reality. Do what the users will be seeing. You might have additional processes that have to run with integrations with other systems you have. You can leave those up, or you can take them down and compare the results. And when it comes to the browser itself, configure it per our guidelines. So make sure it's on a supported version. It's got the right security settings and everything you can find in our docs. And then remove any extensions that users aren't necessarily having installed on their machine. So take off LastPass, or take off your Skype extension, or take off AdBlock, or anything that's not absolutely necessary, because that can conflict with the results. So how do we actually measure the memory? Our preferred method is using Performance Monitor from Windows. This is a built-in tool. You don't have to download it. You don't have to configure it. It comes with the operating system, and it's really powerful. In the demonstration, we're going to be tracking private bytes used by all of our browser processes. What this means is the memory that the browser process keeps to itself, what does it reserve for its own processing? That's what we want to keep track of. The screenshot here is an example of Performance Monitor in Windows, what it will look like. If you don't have Windows, if you're using Mac, you can use the Activity Monitor, which is built into the operating system, or you can download third-party tools like RamMac, Monady, etc. So the tool itself isn't actually the most important thing. What's important is capturing the memory usage of the process and doing comparative testing between your configurations. And so this is just sort of a brief peek into what the code looks like. The testing component's very simple. It's an Apex class, which basically does a SOQL query to return a list of objects. So in this example, it retrieves a set of 500 accounts, and then it returns it up to the Visualforce page. And we do this for a variety of objects because you want to know maybe your account page layout is what's having problems, or maybe your contact page layout is what's having problems. So the actual class has multiple queries, and you can even extend it for custom objects. So if you have a custom object you're worried about, add a query for your custom object to return it to the Visualforce page. And like I mentioned, all this code is in the presentation, which will be uploaded on dreamforce.com for this session feed. And we'll also eventually get a blog post published with all of this data. And the Visualforce page, which is a component, looks like this. It lets you select your entity. So if you want to test on accounts or cases, you can do that. And then you can run, we provide 4 baseline tests. These are the same ones we run. We run these nightly. in order to see if any of the changes we're making in our code have a negative impact on performance. And basically, they either open a bunch of tabs at once, or they open one tab at once, or they open 25 tabs at once and experiences the refreshing. And if you're a developer out there, you can always add more test cases. So this uses the console toolkit. It's a JavaScript library that lets you manipulate tabs. So if you want to open, a bunch of tabs, or if you want to open an email and compose an email and send an email, you can write your own JavaScript code there and perform those actions and just hook into the framework we have provided. And it's demo time. So let me flip over here. I'm now in my virtual machine. I've got my performance monitor set up. I've added counters on the bottom here to map how many private bytes my Chrome process is using. And I've got my beautiful console on the left with the component I've added called perf tests. So I'm just going to choose accounts, and I'm going to run baseline test 1. It'll open 10 tabs, wait 20 seconds for them to load, close them, and then repeat that over and over to simulate what a call center agent might see as they receive bursts of chats, bursts of calls, handle them, and then wait for the next one to come in. And I'm going to actually click it so it goes. Give me one moment. Oh, I was too impatient. It was going. OK. So as you can see, I'm going to take my hands off. The console is going to do its own thing. You can see on the right-hand side, the performance monitor is looking at how performance is going, how much memory is being consumed as each tab opens. And we're just going to let it do this for a minute to get a baseline of the performance that we're seeing with this specific configuration. And in this case, it might not load fully, but what we have is a Visualforce page overriding the view action of the account, and we have 4 custom components that are all loading the account details. So this isn't normally what you would do on your own. This is terrible design, and no one would ever do it except for the purposes of a demonstration. But it's not unusual to have very complex Visualforce pages acting as components. So that replicates what you might see if you have a lot of custom Visualforce here. You can see the memory dips down as the browser attempts to reclaim space as the first set of 10 tabs are closed. And it goes up again. And if I'm lucky, something exciting will happen for your viewing pleasure. I'm going to give it about 30 more seconds before I spoil the fun. But what you would do is with Performance Monitor or System Monitor or whatever tool you're using to capture the memory, you would let one of these tests run out to completion, and then you can save the results, for example, as an image, or you can actually run Performance Monitor from the command line if you're feeling frisky. But I like to take the images. You can see it tells you the last, the average, the minimum, and how long the test has been running. You can track those stats in Excel and then keep them as a baseline series of tests to compare the performance. And I'm kind of disappointed in my demo. So what's supposed to happen is this browser is supposed to crash, and you're all supposed to gasp in shock. But it doesn't seem like that's happening. So let's pretend the browser crashed. But as you can see, the memory profile is not exactly what we want to see after only 4 rounds of tabs. We're already getting between 600 and 700 megabytes of usage. So I'm going to go into my org, and I'm going to undo some of the customizations that I've done. So I'm going to remove the Visualforce override. So it's going to go back to the original account. And then I'm also going to change the page layout. So rather than using the account feed layout, which has a lot of customization, I'm going to say, well, let me just see what the performance looked like from a bare bones vanilla account. I'm going to stop these tests by refreshing the browser. I can't believe it didn't crash. It was more resilient than I thought, which is good 99% of the time, unless you're trying to demo a problem. So I'm going to have you memorize what this chart looks like. Actually, I'm not going to do that. I'm just going to leave it up. And I'm going to run the same test again, but now I've changed the configuration. I've removed all those custom sidebars. And I've also changed it from using a Visualforce override, which is currently, I believe, a known issue we're working on fixing. But I'll show you what a healthy console looks like in comparison. Rather than jumping immediately up to 600 megabytes, and overloading the browser, failing to load, we're actually seeing a modest jump. The tabs load quickly, and were I to be an actual user wanting to do actions, it's very responsive and much quicker than it was with all the configurations. And so this is basically, you would reiterate, keep making the changes to your layout, put those changes in place that I mentioned, try and merge any components you can, put any extra components that don't necessarily need to be displayed right away, make those on demand behind a button or a custom link, and then use Performance Monitor and the testing component, which is provided to do comparative testing with each change you make to understand what the impact is. And so, of course, ultimately, the real test is how do users experience it. Like I said before, if you get to a gigabyte, sometimes you'll have problems. Probably you'll have problems, but it's not guaranteed. I really wanted this to crash because it was going to show you that at 600 megabytes or so, you could actually get a crash if you overload it with too many components at the same time. But such is life. And I believe I'll let this keep running, but it's not going to do anything interesting, unfortunately. So that's it. I hope that was informative. I hope those tips help you configure your console in a way that improves the ultimate performance for your end users. We have lots of time for Q&A. And as I mentioned before, and I'll mention again, the code is within. I've included the code for Visualforce and Apex in the slides. They'll be posted to the session feed on dreamforce.com for this session. And eventually, we will also get this published on our engineering blog with the full steps of how you can set it up yourself in your own org if you want to use the testing component. Yes, would you like to come up, young man?
I heard that you're gonna have a Lightning experience also soon. So is it good for 1 year or it's those tricks?
So we were asking about the Lightning Service Desk, which I believe was announced at some point today, or
not necessarily announced, but I mean, like,
yep.
We know the focus goes on Lightning for everything, so we know it's gonna come. Not like we have no date or whatever, but yeah. What's your vision? Should we approach it differently for the Lightning experience, or what you showed us for this console could be reused for Lightning?
So the same concepts of reducing components and avoiding overloading your browser still applies, but these tips are also very specific to this version of the Salesforce console because of the way it's architected. We do still do we do nightly tests every night to make sure our code doesn't cause any performance regressions. We use basically this component, and we've built a framework around it that captures the data. So the component we're giving you is the component we're using. So you can still continue to test, Lightning with the memory, but it might not yield the same kind of analogous behavior that we see in the console. So this is. Does it use iframes? We've tried to reduce. We've tried to reduce the number of iframes as we realize the memory impact it has. And even in this version of the console, we're continuing to move away from iframes. So if any of you use Knowledge, you may remember a couple releases ago, we improved the Knowledge sidebar. So rather than rendering as iframes, it's actually rendered on the server side, and the markup is returned. So as we move forward, we continue to strip away and reduce the number of iframes to avoid this kind of need to reconfigure in the future. Yep, there we go. And this lovely young man handing out the microphone is my boss. So he's helpful.
Do you find that using omni-channel has an impact on the memory performance in the browser?
Using omni-channel.
With the console.
I see our omni-channel experts winking, but the omni-channel widget, in my experience, hasn't been a main contributor to performance issues. It definitely enables you to hit problems faster, right? Because if you're receiving chats and calls, then you're opening tabs because of just the behavior of omnichannel helps you generate that volume. But the Omni product itself isn't a culprit necessarily. It's more of the way the console is architected and the way you might configure it to handle that load. Okay. And I don't know, did you want to add something? All right. If you want to ask omnichannel questions, you can ask him. He's our an Omni expert. All right. Oh, more questions.
So I'm getting into a console for the first time, and my users want like 25,000 things on the screen at once, naturally. Not really, but like 12. And how do you balance giving a good user experience where there's headers that make sense that you can actually read with, and so breaking things up logically with a screen that's maybe going to make sense if they do for some reason switch back into classic and want to look at it? Because I feel like sometimes these things, when you do switch back and forth, if they need that functionality for whatever reason, suddenly the whole world goes to hell in a handbasket.
Because they have something in console that may not exist in classic.
Well, yeah, if you have the tabs rendered logically in the console, when you switch back into classic, maybe they're not ordered the same way because the classic experience is different. But then you've got Visual Force components that are doing other things too, and it just so how do you kind of manage all these different things, or do you say like just no more classic? Everybody, you're in the console now, and deal with it.
I think it will definitely depend on your org and how your users feel. We definitely recommend if you're in the console that you live in the console. You don't leave the console because the console is better. Don't tell anybody I said that, but the console provides, like you mentioned, the enhanced experience of having those sidebars and those headers that give you the context you lose in the classic experience. So, if it's feasible, you can recommend putting all your users in the console and say, when you're working in the console, this is what you get. When you leave the console, it's a different experience. You can't necessarily expect the same things. One thing you can...
I can actually add to that. So I was in support at Salesforce for a long time, and we made the decision to, really it's one or the other. So, people are either a user of Classic or they're a user of console, but we've tried to encourage most of the support agents to use console.
Yep. And even ourselves, the developer team that works on the console, they work in console. As you know, we drink our own champagne here or eat our own dog food, depending on how humble we are that particular day. But we use the console so we can experience what it's like to live there. And, it's led to a lot of enhancements like being able to control-click to open new tabs. Or this might be safe harbor. I think we released a browser extension that lets you consume all actions that happen in the browser. So if you have an email that sends you to a Salesforce link that isn't the console, if you click it, the extension will say, and it will take that and put it in your console for you. And so it really helps you, live in the console. All right. I'm going to shut this down. I'm going to hang around if anyone has more questions or wants to grab a business card or anything. But thank you all for attending. I hope this has been illuminating and will be beneficial for your users.